All right, so welcome to second Productboard Frontend Meetup. For today, I have prepared to talk about quite familiar topic, which are loading spinners and skeletons. But first, let me introduce myself. Uh, I'm a software engineer here at Productboard. I joined last year during just when the pandemic hit. And in the last 7 years, I went through various technologies like Angular. I worked with Ember, and now I work with React. However, in my spare time, I spend quite a lot of time behind the camera. So photography is my hobby, and also I ride on electric unicycle. So if anyone wants to have a chat about any of these topics later, uh, reach out to me. All right, let's take a look on the agenda. It's loading. Yeah, actually, that's what we are going to talk about today. First, I will show you what kind of performance issues we had in Productboard. Next, I will talk about some approaches how to deal with them. And third, I will show you what was our solution and what issues we had during that. And at the end, I want to also show you how design system helped us with this case. So let's begin. When I joined Product Board, the Product Board was really slow. The initial load took quite a long time, and it's not surprise because actually the main JavaScript bundle had almost 11 megabytes. Uh, and you probably know that it's not about like downloading the JavaScript to the client's browser, but it's also about the parsing the JavaScript and executing. So this is how the bundle report of Product Board look like, and you can see that there is like a huge main.js chunk where is everything. And this really means that when user comes to a certain page where he doesn't need like a lot of other stuff from Product Board, he needs only the specific code for that page, right? So that was the solution, or that was what we need to solve in Product Board. And so we decided to slice up the Product Board into smaller chunks. Uh, and we decided to do that by routes. So basically, every page will have its own JavaScript file. And for that, there is a well-known approach in React called code splitting, and it's really easy to do. You can basically lazy load any component you want. You create a function which can import a component. Using this webpack directive, you can specify the name of the chunk. So you can even do that. You have like multiple pages in one single JavaScript file. And then you pass this function to React Lazy, and the React Lazy will create a component for you. This component can be used together with React Suspense. And the way how it works is that when it's supposed to render, the suspense will wait for the JavaScript for this lazy component to be fetched, and then it will display it. Until this is finished, it will display the fallback. In this case, it's the loading spinner. So using this approach, we identified about 60 chunks in our application. And so this is how the bundle report looked like after the splitting. And we effectively decreased the size of the main JavaScript bundle from almost 11 megabytes to 3.8 megabytes. This helped the initial load tremendously, but there was a new problem which arose. And that is when the user tried to navigate somewhere. The browser had to fetch first the JavaScript chunk for that given page, and there was a delay. So we were dealing with the problem that we have to like identify the loading state of the app. So now we had to take a step back and think about like what are various approaches to this problem, right? So the first one, how you can identify the loading state, is obviously the loading spinner. So this one is the most easiest one because it's usually just a simple React component. You place it to the DOM and you remove it when the fetching is finished. But it doesn't give user any information like uh, it's just it tells the user just that something is loading and that's it. Another approach is to use a progress bar. So this is great because it gives the user information when it's going to finish, but you can use it only when you have an idea, or at least you can approximate somehow when the data fetching is going to be finished. There is one exception. Do you know any software which shows the progress bar and it has no idea when the fetching is going to be finished? But I think I've heard it. It's Microsoft Windows. Do you remember that copying a dialog where they were telling you, okay, 1 minute left, but they were showing that for ages. There is one more thing which you can show to the user when loading some page, and that's the loading skeleton. Not this one, but this one. So this is, from user's perspective, this is the best solution because it gives the user idea how the layout will look like, where the content will be, where some controls might be, and so on. But obviously, it has this advantage that the effort to implement this one is the biggest, because basically for every page, for every use case you have to craft a specific skeleton. Yeah, so higher effort. And also, this is something what you can show to user. Nothing. This is really useful when the loading is really fast, because like showing something in that case is more distracting than helpful. So let's look at some things which you should not really do. So I'll start with this one. Showing multiple spinners on a single page is not really good approach because it's distracting for the user. It gives him so many places to look at, and instead, like you could show just a single spinner for the whole page, or even better, design skeletons for each part of this page. Another thing which I've seen in my career is when there is no reaction on the user's action. That the user clicks on something, but there is no indicator that something is happening. And this was really common in the Angular world because the Angular router allowed you to chunk the application like we did in React, but in some versions it didn't allow you to track the progress of loading. So you click the link and nothing was happening. So for that, a simple solution is to show at least some progress bar or something to indicate that that the page is loading. Next one is something what I call short spinner, and that means like showing the spinner for really small period of time. That's really distracting for the user because he sees that there was something, but he's like, oh, I didn't catch that. What was that? So for this case, it's really better not to show any indicator at all. The opposite of this one could be a long spinner. A long spinner is the like showing the spinner for a really long time, and for these cases, it's much better to use the skeleton. All right, so back to our product board problem. So I told you that we split the application into almost 60 chunks, and you can already see that some of them are big and some of them are small. And even by just clicking through the application, you can identify that there are basically three cases. Uh, there were some parts of the application which loaded really fast. Those ones were great, or we decided to not to use an indicator at all. Then there were some parts which loaded like reasonably fast, but they would deserve some kind of loading. So there we wanted to show spinner. And obviously there were large pages which like loaded several seconds. So there we wanted to show skeletons. And for our case, we decided to set these thresholds that if it's faster than 300 milliseconds, we will show nothing. If it's longer, we will show the spinner. And specifically, we knew that there are certain pages which which loading takes a real long time. So there we wanted to show skeleton. Yeah. So during implementation of this idea, we were facing two main issues. The first one is the suspense fallback was rendered every time. And this was not really handy for various cases, and I'll talk about that more in depth later. And the second one was that we had to somehow identify those slow pages. We had no idea which pages are slow and which are quick. So let's talk about the first one. So the fallback is rendered always. What does it mean in our case? It means that the spinner is displayed even though it's not necessary to be displayed. The great example of that is when a user opens a page, then he navigates elsewhere and comes back. And when the page was lazy loaded, there was always a spinner, although the JavaScript bundle was already loaded in the browser. So there is no reason to show spinner for that case, right? So let's take a look. What is even this suspense thing? So suspense is a special component which prevents rendering of its children, and it waits for them to that they have to be like ready to be rendered. And although this whole API thing is experimental, this part which is used with the React Lazy and Suspense, this one won't change and should be safe to use. So it prevents rendering its children. So you might be wondering what kind of magic it is. And the implementation is really simple. It's just like this. It literally tries to render the children. And when this rendering process fails, and in terms of the suspense, it means that the rendering process has to throw an exception, it will render the fallback. And now you might be wondering, like, okay, when the first render fails, how does it know that it's supposed to try it out again? How does it know that it should retry the rendering? And the trick here is really smart and like really easy. I would say really smart, yeah. The thing is that the exception which is thrown here is actually a promise, and Suspense will hook up on this promise, and it will wait for it to resolve. And that way, the children components tells the Suspense that it's ready to be rendered. And then the re-render is triggered. All right, so what does it mean in our case? So the fallback was always rendered. It means that the first render of the React Lazy component, it always thrown an error. So it always like goes to into this catch branch. So we got this idea to postpone the rendering of the fallback to avoid this behavior. And we came up with something what we called a delayed component. And I will show you the code, and it's really easy. And one of my colleagues, he called it like a masterpiece of engineering. All right, so this is how you use it. You can wrap any component, you pass a delay, and the children will be rendered only after the delay. So this is the implementation. Let's go through that really quickly. So it gets two props, the children and the delay. And there is a condition at the end, and when like there is an internal flag, and when you should display the children, it will render the children. When not, it will render nothing. Initially, we set this property to be false, obviously, and we set it to true after a certain period of time, after the delay, right? So this is just a code which postpones the rendering of a component. All right, so this solved our issue because now we've wrapped the spinner, so it was rendered only after a certain period of time. And when when the suspense failed, like in the first render, it showed nothing thanks to the delayed component. All right, the next issue we had was to identify those slow pages. So the problem here was that we had no idea what pages takes long to render. You know, Productboard is quite a huge project, so there are like a lot of components, and we basically went through all of them and like converted them to lazy, but we had no idea which one were slow. So we decided to use to track the delayed component lifecycle for that. Because in this delayed component, there are these three events. The first one is obviously that it's being rendered. That's when the suspense renders it. Then we have 300 milliseconds when we do nothing. And then we show the spinner, right? So that's like the second significant moment of the delayed component. And the last one is when the delayed component is unmounted, because that means that the suspense reacted for fetching the data. The fetching is complete. So effectively, this means that the page was loaded. So just by tracking this component unmount, we are able to identify what components take long time to load. And we used Honeycomb for that, which is a great tool if you want to track any kind of information and maybe do some kind of like graphs or analytics upon that. And it gave us visibility into like which components, which parts of Productboard are huge and slow to load. So by this, we identified these slow pages, and we were able to specifically craft skeletons for them. So job's done. Good. The last thing I want to show you is how design system helped us in our case. We have a dedicated team for design system. The design system is called Nucleus, and it really helped us to craft those skeletons easily. We have there a component which is specifically for this purpose. You can, I doubt you can see it from far, but you can just pass it various props. And thanks to this, you can build, okay, this is almost invisible, but trust me, there is a skeleton, and you can build like the UI skeleton really easily. So it's really great thing to have, and huge kudos to our design system team. All right, so what should you remember from this presentation? If you have some problem to solve, first measure, get some data based on which you will make the decision, and then do the research. What are possible decisions, and pick the best one and give the user the best user experience. Also, I wrote an article about this one, so feel free to check it out. I go there more in depth, especially in the part about the honeycomb tracking. So yeah, that's it for me. So I think it's time for Q&A. All right, so the first question, did you get any feedback from the users how the feel of the app changed? Actually, I don't think so. Like the change was not that visible, but we definitely tested first this deployment of this change here internally. So we basically solved our issues before going to GA. So, but I don't think there were any complaints related to the app performance. All right, so should the delay component be part of the fallback spinner? This way you delay an already fetched component unnecessarily. This way you delay already fetched component. Well, that was the problem, right? That the already fetched component was I'm not sure if I understand the question correctly. Yeah. Yeah, it delays the rendering of the spinner. But thanks to this suspense, it's like always like it's rendered in like next rendering phase. Yeah. Yes, that's correct. It's not 300 milliseconds actually, because the suspense will see that this component is fetched, so it will render it immediately. But it's not during the first render cycle. It's during the second render cycle. But that one happens really instantly, basically. Yeah, yeah. Yeah, it is wrapping the loader, because that's the thing which we want to postpone for later. You know, the suspense will always show the fallback. I can go back in slides. Yeah, sure. Da-da-da. So here, oh no, all right. Da-da-da, da-da-da. Here? No, no. Yeah, yeah. It's the spinner which we wanted to show later. Mhm. Will there be only one spinner? Maybe. Like, yeah. Mhm. Yes. Yes, good question. No. Uh, so the question is whether there will be only one spinner, because we have like chunks per page, right? And the answer is no, because we actually use like nested routes. So it might happen then that one part will load earlier, and we also have like sidebar in the application, and these are like separated. So there might be like one part of the app loading and the second part of the app loading. However, we use the skeletons for these like big things. On which machine? Oh, that's a great question. On which machine you measured the performance, developer or user ones? You know the speeds are usually far different. Yes, that's a very good question. So we measured that on a user's machine. And that's the honeycomb thing that like we basically released to GA this measuring. And so we receive data from user's machine, and we could also see like what is the difference between the slowest person and the fastest, right? And we basically took the 19th percentile. So we aimed for the most of users. Yeah. For recognizing the slow pages, you are assuming a reasonably fast internet connection. Have you considered also? Have you considered also factoring in the user's internet speed? I think this is really a similar question to this, like that people have different connections. Yeah, again, we aim for the like 19th percentile, and the thing is that the user base of Productboard, those people have usually quite a good internet connection and even a good machine. So the difference between the slowest one and the fastest one was not that huge. Is initial Productboard slow to considered like a spinner? If yes, shouldn't be a skeleton. Oh yes, that's also a good question. It usually takes more than 1.5 seconds. Yes, so when you boot up the Productboard application, there is like data fetching going on in the background, and there is like loading animation. And yeah, that one is basically a spinner, I would say. And the question is whether it should be a skeleton or not. Actually, a good thing to consider. Yeah, and we are recently we implemented a feature which basically skips this loading animation, and it shows the data as soon as possible. Um, and then the original thing which user navigated to is a skeleton. So yes, basically we are going in the direction. So are pages tracked? Like if they size changes, then use spinner or vice versa. So is this question about like whether we have like different pages with the spinner and some with skeleton, and by time that they change, that maybe the skeleton would be better for that? Yeah. All right. So we don't track these changes. We have. Because the difference between like those pages which took several seconds to load, you could literally see them on the top of the list, and then there was long time nothing, and then there were those like reasonably fast. So we don't track the change. However, it's a good idea to go and revisit it, whether maybe some of those pages maybe it jumped over 1.5 second, because in that case we would have to craft a skeleton for that. Do you have any advice when you are waiting for data from backend, from API, but have no idea how long will the response take? All right, so sometimes I'm just like thinking about that maybe you could send in HTTP header some kind of like how much data is going to be transferred to give the user an idea. Or maybe you can like do some kind of pagination that you load data like progressively, or you can write a game and show him the game to play until the data fetches. Did you consider CSS animation delay over set timeout when showing the spinner? Yeah, all right. So I think no, we have not, and the reason is because in the example I showed you, there is the loading spinner, which is simple component. But maybe the fallback could be the game I just suggested to you, right? Which could be quite expensive component. So we don't want to really render it every time. So that was the reason. But I think this would be viable solution for certain cases. Is it a good practice to rely on some delay in set timeout since it's also dependent on the performance of used hardware. Are there any other solutions? This is a good question. And we could actually see that because I told you we tracked 3 events of the delayed component. The first one was rendered. The second one was when the spinner is shown. And based on those trackings, we found that it's really, really accurate. That it was like 300 milliseconds and maybe plus minus, I don't know, like 10 or something like that, you know. So based on our measurements, it was quite accurate. So I think there is no reason for any other solution. With Suspense, have you also considering using some delayed fallback component instead of extra delayed component wrapper? I think we could use like delayed fallback for the part with loading spinner. That would work fine. But the advantage of delayed component is that you can pass there any component. So this is handy, especially for like those pages which need skeleton. So you can pass their different skeleton every time. All right, any other question? If not, thank you.